Hello everyone, in this video I'd like to discuss how can we read one IOLink device event information. This is an uncyclic communication via Siemens PLC and perfect night communication. And as we discussed from the previous video, IOLink support 4 data types: process data, value status, device data, and events. Process data, they are regular I/O inputs or outputs. Value status, basically, this is a PQI, some quality bulls. The device data, this is basically the parameters of the sensor or actuators. Then, if the IOLink device has any errors, to troubleshoot these devices, the more information will come from the events. For example, in my case, if this object is very close with this IOLink device sensor, or this sensor can detect nothing is far away, then this sensor will show some events alarms. For example, either no objects or the objects too near. It will show those events. Then how can we use PLC to read those events? This will be about using the function block, the diagnostic function block, to read the events. Okay, so in this video I will use IFM LIOLink03, this IOLink master, and this IFM05D150, this measurement sensor as an example. And IFM supplied one sample program, and I will use this sample program as an example. This is basically diagnostic function, so it could be commonly used for cross the different brands. So this is one method. Then if one day you have other brands, IOLink master or devices, you can use a similar way to diagnose the events for IOLink devices. Alright, let's firstly go to the website of IFM. And since I'm using LIOLink03, this IOLink master with a perfect night function, and we will find one sample program if we scroll down and we go to the downloads. And we can find, since I'm using Siemens PLC 1500 PLC TI Portal program platform, and I will download this sample program. After we download this sample program, we can jump in and go to the diagnostic IOLink events. And from here, it has step 7 sample program and the TI Portal sample program. And it has TI Portal version 14 or TI Portal version 16. So since now commonly TI Portal version, they are above 15. So I'm going to use TI Portal 16, this sample program. And currently in my laptop, I'm using TI Portal version 18. So I'm going to open this. Meanwhile, if you like to read more details from this instruction, you can open this PowerPoint. And this PowerPoint explains the basic idea of this sample program. However, while I'm using this sample program, I had a little bit trouble on this. And on the way, I will show how I correct this trouble. Allow this sample program can be used in my demo project. Okay, let's firstly jump to the IOLink master. Alright, now if I'm going to open this IFM Moni, this IOLink master configuration tool, scan this master. Okay, then let's jump into this IOLink device. Okay, let's go to this dashboard. Okay, currently this dashboard can display the status of this measurement sensor. Now, if I'm going to reduce the distance 8 centimeter or increase the distance 12, so we can see the status. And now, since it's currently is in the normal status, then from this event area it has nothing, because currently it is correct. But now if I'm going to be very close, okay, so it's showing the error there, and we can see it shows this events HCB0, object too near. And now let's open the manual of this IOLink device sensor 05D150, and we can see this event code HCB0, the objects too near. Okay, it makes sense because now currently my object is very close with this sensor. Okay, if it's very far, so now if I'm shooting this sensor to very far distance, okay, it's showing nothing there. And then let's see the events. Okay, And this 8CB5 is no object, this event. So as we can see, the event can display the more details of this error status from this IOLink device. Alright, now the thing is, how can we use the PLC to read those events number? This is talking about uncyclic communication by using the function block and allows the PLC can read the status from this IOLink device. And it's not the same as the regular process data. We have to use the function block. Fortunately, IOLink supplied this sample program as I introduced here. And now I'm going to open this sample program. And based on my existing demo project, I will open both projects. The sample project will be the left, and the right-hand side will be my existing demo project. And I will copy the essential function block from the left to right. Okay, let's do that. Now I'm going to open it. Currently, I'm using TI Portal version 18. Okay, so now I'm going to use version 18, open this version 16. I'm going to open this version 16 project. All right, upgrade. Okay, so this simple program, it has 1200 PLC. And it's showing it is using AL1402 as an example. And here, this IOLink master AL1402, it had 8 ports, okay? And from this project block, it has OB82, and inside the OB82, it has this program. So it still is showing FBD still, but we can change it. So we can go to this property and we can toggle to LED if you like this way. From Siemens PerfectNet mechanism, so if there's any error from the PerfectNet field bus, so the system will trigger OB82 diagnostic error interrupt. And when the system call OB82, so it will have a chance to call the read system time. And this allows this error can be captured. And this time will be also input to this alarm collector. So this alarm collector provided from IFM. So this alarm collector collect the information into this DB, alarm collector DB. And this alarm collector DB locate to here. So if we open it, and then we can see it's showing the max array, alarm buffer, and the last entry. Sometimes maybe your system has a bigger system, so sometimes those parameters might need to change, okay? And this is the alarms, the buffer, okay? So once the system call OB82, this FB7 will collect the information to OB1, okay? Then from the OB1, so here has 2 examples, alarm 1 and alarm 2. So let's open the OB1. Firstly, I will switch this OB1 to ladder style. Inside here, this sample program supplied 2 examples. It demonstrates if this master has 2 IOLink devices from the port 1 and port 2. This is basically the port 1. Each port needs 1 alarm call. So that's why here, if we assume there are 2 ports, 2 IOLink devices, there are 2 instances by using this FB6. This FB6 supplied from IFM, the function block. And here, this hardware ID, so they came from here. So if this one is a port 1, the hardware ID came from this system instance, okay? And the second one is 280. Okay, the first one is 279. Okay, that's why here 279 is the first one, 280 is port 2. Okay, but this is not ideal way. I will demonstrate how can we use this properly. And here has an alarm acknowledge and reset. At the right side, we can capture the events. Okay, and the bottom here, there's one collector reset. Idea is if we like to reset the buffer, so we can trigger this bool. Okay, now let's copy those sample program, go over to my project. So from my right side, this is my project. We will not start from the scratch. From the previous video, and in my project, I'm using AL1102, this IOLink master. I'm connecting with O5D measurement sensor, O5D150. And this O5D150 is using 2 bytes as the process value. And from these properties, so here, this is my vendor ID, device ID. Okay? And I'm enable this IOLink events. So be careful. So don't forget to enable the IOLink events, because this video we especially like to show how can we capture the events. And this port 1 is hardware identifier is 271. So be careful of this. Okay? And now I'm going to copy the alarm collector and this instance. Okay? And let's copy it. Copy and paste to the program. And meanwhile, I will also copy OB82. Okay, right side, copy OB82. Meanwhile, don't forget, there are also date types. So under this folder, it has date types here. So let's copy and go to my PLC date types and paste. Okay, after copy, so we can see it copied here. And then let's quickly go through. We have to do some slightly change, adapt to my project. Okay, OB82. So from here, once the system has diagnostic request, so it call OB82, the PLC automatically call 82. Then we capture the time. And then we capture the letter, the arrow where they came from. For example, my IOLink device is hardware identifier number is 271. So once this device has something wrong, this OB82 will identify this 271, this letter number. And this letter number and the time, when it occurred, then this IP7 will capture. After capture, it will store the information into the hidden, this DB collector, this alarm collector DB. Okay, so we better write one description here. So IP7 will collect alarms into alarm collector DB. Okay, and then we open the DB and we can refresh it, update. Okay, so because we copy over, let the system automatically join together these date types. Okay, the maximum buffer is set 3. This 3 means each port, it will stack 3 buffer, 3 alarms behind. Okay, the maximum array, so from this array is set 20. So we will leave as a default here. Okay, and then go to the OB1. So quickly review, in the previous video, I introduced how can we use this process data, read the process distance, and how can we store this PQI info. And then how can we read and write parameter by using the IOLink device, the library, okay, the parameter read and write. Okay, now I'm going to copy the sample program from IFM program, and it will be the event. So let's go to the OB1, and we can copy one alarm from here. Okay, since we only has one port, one IOLink device, so I do not have to copy the second one. Keep in mind, each port will need one instant, this IP6 instant call. Okay, then I will copy this reset alarm just under this. Okay, so we can call here O5D150 measurement IOLink sensor. Okay, and from this alarm, this is instant DB, and this instant DB, we probably can change this DB name. It is IDB instant DB for AL1102 port 1. Okay, AL1102 port 1. Okay, this instant DB, and this hardware ID. Okay, so the hardware ID, ideally we should do this: PLC tags, go open, and go to system constant. Okay, and scroll down, and we can find 271. It is my port 1. Okay, port 1. This port I'm currently connected with my IOLink sensor. So we need to drag this 271 to this port. Okay, here. And if we quickly recall from the hardware configuration, okay, my hardware configuration, this port 1, so 2 bytes plus PQI, it is the same name here, okay? And this port, again, if we go to the properties of this port, and here it's showing this system constant, it is 271. Each system will be slightly different, so you have to figure out this method to find out the correct number from your system. And here, this is DB5. DB5, this alarm DB, so we can refresh it. Okay, we refresh this UDT, this date type. Okay, behind it is doing this way. And this DB, this checkbox is off. So that's why here it has offside. Once we compile this DB, the offside will be displayed here. And then the question mark from here will be disappeared. Okay, so now currently we are using this alarm 1, alarm 2, alarm 3, alarm 4, alarm 5. This basically represents ports. So basically say this alarm is an alarm for port 1 and port 5. So we prepare those. If you are using one IOLink master, it has 16 ports. So don't forget, you need to create from port 1 to port 16. So each port will have one instant DB, and also the variable specific for this instant function block code. Okay, I'm gonna close it. All right, now we can download this program and we can try. All right, save the project and let's compile the project. Okay, now I'm going to download this PLC. Okay. All right, so we download this PLC and let's go online. Okay, everything green, and from the right side, my controller is running, and currently there's no any alarm. Okay, and if we go up and go open this process data, so it's reading 10, everything is normal. But this video will mainly focus on this events now. Okay, default it is 1917, so that means okay, there's no any new triggered timestamp. Okay, now this is default. Okay, so now the value is normal, but in case I move this block to very close, okay, and we can see it triggered the alarm. And the trigger alarm, the latest event is ACB0. Okay. 8CB0 is object too near. Is exactly matching the case what happened here. And the system also shows error. We can jump to the go online and check this diagnostic buffer. And from here, we can see the system triggered the alarm, and it came from this port, so it shows which port has alarm. And now we can remove this event and let the system return that to the normal. And now we can see the alarm from CPU, it recovered. But this buffer, this code, we haven't acknowledged yet. That's why it still shows alarms 3 happens, because when I'm moving, it triggered a couple of times. So it's showing this alarm still there, so we can acknowledge it. Acknowledge a buffered 3. Okay, we can acknowledge. Okay, so this is the case I found from this sample program. As we can see, almost the last alarm, I'm doing the alarm acknowledge. We will see, unfortunately, CPU stopped. So let's troubleshoot what happened from this alarm diagnostic. So if I jump in and go to this alarm, CPU was stopped. And CPU stopped. Let's go to the reason here. Just before stop, it shows this array length error in FB6. And here, this is description. And if we open in editor, it will jump to the reason where it caused the stop. It came from here. This is the IB6. IB6 is being called from the OB1. Okay, this is the IB6. Inside this IB6, from this OB1 here, if we jump in, this line 195 is showing this alarm qualifier here has something wrong. Actually, problem come from this. The index has something wrong. So if we right click, go to the definition here, as we can see, this UDT alarm array from 1 to 3. From 1 to 3. So let's go to this UDT. If we go to this UDT, okay, this UDT here, the alarm index just from 1 to 3. I think the trouble came from this. Once we acknowledge, in a short moment, this alarm index from 1 to 0 because we try to clear this alarm. So once the index change to 0, a short moment, it doesn't have 0. That's why the system show the alarm and the CPU stop. This is one typical problem cause the CPU stop while we are index one array, but the array size doesn't match with your index number. To prevent this, we can insert programming error, this OB, and download into CPU. This can prevent CPU stop. That doesn't mean this problem is solved. The programming error, this OB, once we insert and download, it can prevent CPU stop. However, this index problem is still there. So based on some tests I did, I found if I change this index from 0 to 3, basically allows the system has a 0 this index. Maybe the 0 is working for nothing, but if the index change to 0, it will now blow up the CPU. So now I change to 0. Let's compile because some place is referencing this UDT. Let's compile and let's download. Okay. Meanwhile, let's restart the CPU. Okay. Now let's go online. Okay, so this time, now currently it's correct. So if I remove this object, I'm shooting a very far away. It's getting no object. Okay. And we can see it triggered two alarm. Current alarm, it is 8CB5. And from the menu 8CB5, it is no object. So it's very far away. Okay, now if I acknowledge again, okay, now index to 1. So this time let's watch here. If I'm trying to clear the alarm, clear. So this time will not cause the CPU stop. Okay, this is I found the solution for solving this one glitch from this OB, from this IB6. Okay, so let's do again. If I move closer, no object. Remove, and far away, just to trigger some alarm. Okay, no object. Okay, maximum it triggers three buffers, and now if I acknowledge, okay, I also trigger HCB0. Let's see, HCB0 was object too near. Okay. Okay, let's acknowledge 1. And trigger set to 0, and CPU doesn't matter. Okay, it will not causing the CPU blow up. And this is acknowledge. Every time we acknowledge, this buffer will be reduced to 1 index. Another way is we can trigger this reset dB. Okay, once we trigger, it clear all the buffered alarm. Okay, so this is the function block provided from IFM for capture the events from the IOLink device. And if we jump into this alarm, IB6, so this is the basic idea, the program for sorting out the information from this alarm collector DB. So alarm collector DB, this is the buffered alarms here. So the alarm logic inside can be not only used for IFM, if you have any other brands, say you have a IOLink master or IOLink device, this IP6 should be very common. Okay, this short video to demonstrate how can we use this simple program from FM, this alarm IP6, as well as the OB82, this IP7 to collect the information and capture the events. Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe and hit the bell. Thank you for watching.